Good morning and good evening, everyone. This is our session on C# custom actions, mainly in InstallShield, but we're also going to be talking about basically how they work in WIX and taking a look at the WIX solution. And time permitting, we'll see if we can also look at it not just from the InstallShield managed custom action support perspective, but also using it from InstallScript, since there are capabilities of hooking into C# directly from InstallScript. So I'd actually like to start by taking a look at the InstallShield managed solution for this. Create a new basic MSI project and hop right over to the custom action view. Something that's probably familiar to the most of you. And starting, I think it was InstallShield 2008 or 2009, we were given this new managed code type custom action. Typical types of options for this: stored in the binary table, installed with product, path referencing a property. Something you've probably seen before with MSI DLLs or executables or things of that nature. For the sake of simplicity, we're just going to select the stored in binary table, where it allows us to browse for a .NET DLL. And I'm just going to grab some arbitrary guy to show you basically the browser for methods within a public class. Let's see, I'm going to get something mildly useful sounding here. We'll say system.directory services. The ellipse button here lets us actually pick a class and a method within the assembly. Again, so it has to be something that is marked as public for this to actually show up in the view. And as well, by default, it's going to hide anything inherited from system.object. So we'll expand here. Gives us a nice browser for public methods within various classes. I'm just going to grab an arbitrary one here just to fill out this form. So let's grab one that actually takes a parameter of some sort. Okay, something with a Boolean value. And it actually goes through and fills out the method signature based on what's actually in the method. Now, since it takes a parameter, it also lets us choose what we're going to pass through to the parameter within the method. And in this list, it shows us basically the contents of the property table. And it's actually cut off at the top here. So there's actually one thing that I want to show you. This is pretty straightforward in calling methods, but there's a couple special things that we have. Aside from MSI properties, we also have this MSI handle, or a literal value of 1. The MSI handle is what I want to focus the most on here. So obviously this method is not prepared to take the handle to the MSI. But what's special about this is that the MSI handle, as probably most of you are aware, is what allows us to call into all of the Windows Installer APIs. Pretty much the vast majority of the Windows Installer APIs that are going to interact with the installer need this MSI handle, and that's why this is a special parameter that we can pass through. So as you might expect, there's a lot that you can do directly from C# once you actually have the MSI handle. And so this is kind of a good jumping off point to actually get out of InstallShield, which, for the most part here, other than this, method browser, it's pretty straightforward working with the managed custom actions. So we actually want to get into working with the APIs from within C#. That's actually probably what requires the most time here. I actually already have a sample project set up, but for the sake of illustration, I'll actually create a new project for us to get started with. And as you can see in my history here, we'll get back to this later, but WIX obviously has a C# custom action project type, which is very different from what we're going to look at first, which is just basically a completely vanilla C# class library. So now we have our empty public class. Now, before we can really do anything, we need some kind of exposure to the MSI APIs, because if you look around, there's nothing by default in C# that allows you to talk to the MSI engine. Pretty much, Microsoft hasn't built in any kind of support for managed custom actions into Windows Installer, and no Windows Installer features into .NET. Interestingly, there's some people at Microsoft that actually think that managed custom actions themselves are inherently a bad idea, which is why, very likely to begin with, that there's no native support for managed custom actions. If you'd like to read up a little bit about this, there's a very interesting article by Aaron Stebner on don't use managed code to write your custom actions. To sum up, actually,
can you not find an article like this for every different type of custom action?
Yeah, pretty much.
Don't use VB script.
Yeah.
Don't use JavaScript.
Exactly. And actually, that's exactly why I wanted to actually bring this up, because his concerns, while valid, are really more about corner cases. Reading through this article, he says, hey, it adds an additional dependency. Well, in this day and age, .NET's on everything. He brings up the issue of, it's going to cause your installer to fail if the .NET framework is damaged. He talks about runtime policy migration issues. He talks about a .NET custom action potentially running on a different framework version than it was authored and tested in, which really, again, is more of like a QA issue. If we know that we're going to be deploying to machines that have different various configurations, then we need to basically test that in our QA process. So all of his concerns are, from our perspective, I think, not major concerns. Corner cases or things that are handled with a QA process. So it's still a good read, especially for all of the dissent that people in the comment section bring up. So in any case, we need some kind of access to the Windows Installer API, all of which is provided by msi.dll, or also there's actually some COM objects that you can use for that. My preference here, there's actually several different ways to hash this out. I'll actually start with the lowest level option, which I think probably Garrett, you and Robbie may have worked with Ada on this. I had provided her a solution of this sort when she was writing some C# custom actions. And that's, I wrote a little Interop class that basically uses what they call a platform invoke to wrap all of the methods and all of the enums and all of that good stuff for the MSI API, so you can easily call it from C#. So I have the Source Control Explorer up here. If you guys were curious, it's in the TouchWorks code base under this main installation, install tools, config crypt CA. It actually pops up a couple of other places. Basically, it's let me just bring it into the custom action project here. We'll add a existing item, browse to it. And I'll show you basically what it is here. So all I've done in creating this little static class is I went through, first of all, the entire Windows Platform SDK, and I pulled out all of the enum types that are relevant to Windows Installer. So MSIDB control attributes, all of the MSI errors, all of that kind of stuff. So it's handily available in this static class that you don't need to instantiate from within your custom action. And the second thing that I did was I went through, there's a website that exists for nothing further other than to provide function prototypes for C# for native DLLs. And I went through and I grabbed every single MSI API call, and I massaged them a little bit because there's not a great deal of consistency. There's some of them that use ints for the MSI handle. There's some that use int pointers, and I kind of made them all, relatively consistent, and defined all of the function prototypes so that we could call them directly from C#, and then the framework would know basically how to call the MSI APIs in MSI DLL. And then the third thing that I did in this class is I just wrote a couple of helper methods that we'll come back to when we actually get to coding in the custom action itself. And what's nice about this is that we add no external dependencies to the custom action runtime, which is something that we're actually going to talk a lot about in this session, because there's different ways of handling this depending on how you're actually using your .NET custom action, be it from WIX, be it from InstallShield, be it in InstallShield using WIX, which is actually, there's a couple ways of going about that. No, so I just need to invite Rohijit to the link meeting. Okay, thank you. So now that we have our first option here for working within a custom action, we need to define a public function to call from our managed custom action in InstallShield. So what I'm going to do is I'm actually going to kind of follow the standard custom action model that you typically have to follow for C++ and InstallScript, which means that it passes back an integer to the MSI engine to determine success or failure. It takes an MSI handle as its only parameter, and then it uses the MSI API for communication with the engine. I'm using an int pointer data type for the MSI handle, although an int data type also works. So what we'll do, just to start with, is just to make it compile, we'll have it passing back.
This microphone's probably working too.
Okay, let's see.
That's your speaker.
Are we getting echo?
Yeah.
Still getting echo.
I'm on the line. I can't hear any echo.
Yeah, we're getting an echo in the conference room.
Oh, okay.
Okay, I think we're okay now. Okay, so for the moment, we're just going to pass back success, error, error success, which, for those of you who don't know, is a value of 0. And of course, because it's part of an enum, we have to cast it as an int. That we'll actually see again when we get to working with WIX custom actions in InstallShield. So now we have this MSI Interop class that lets us access all of the MSI API. And like I say, if you're familiar with doing this in C++ or InstallScript, there's not much of a learning curve here because the syntax is very, very similar. It's just basically in .NET data types and syntax. So, for example, if we wanted to use MSI get property, product name, and of course we'll need to create a string builder. Instantiate string builder, for the buffer.
So can't we like just use normal string type? Like, why use a string builder?
Well, so the string builder is a managed data type that you can pass through a reference to. The way I had this explained to me by an InstallShield developer is that by using a string builder data type instead of a string, you are using a safe way of giving the MSI engine access to .NET memory, whereas it does it in an unsafe way when you pass it through as a string, as a reference to a string variable.
So maybe this might be the reason that we had to do the scrub also when, remember, I was...
Yeah. So there's actually a very good reason for that. We'll get to that time permitting. So in any case, what Ravi's talking about is there's a lot of problems that you can run into when you're calling functions in a managed DLL from InstallScript. And we ended up, in a couple cases, having to use a special function that we wrote called scrub to basically have the variable make it through successfully to a .NET function. Now, if you're curious about reading the specifics of this, I had attached to this meeting a couple of Word documents that I had written for the Flexera Install Talk blog. The second one details the problem and the solution and the background specifically to that issue, and it explains in great detail why a scrub or a clean function is needed and how it works on the back end. Now we define the buffer value and pass that through, and what are we missing here? It is wanting, yeah, so we have to, there we go. So we have to put the ref keyword in there to make it possible for the MSI engine to modify the value of this buffer. Because as we know, the buffer value, it goes in telling it the maximum size of the return value, and it comes back with the number of characters that's actually in the property value. And so now we have a simple custom action with my static interop class here, no external dependencies, that doesn't do anything useful yet, but it grabs an MSI property using the MSI handle. So this is one way of doing it. Obviously there's a lot of low-end calls to the MSI engine. This way, it's not super duper, I guess, safe, because you're calling out directly to everything. You need to put a lot of work into exception handling and things of that nature. Whereas if you use a more full-featured interop library that uses an external dependency, there's a lot of that work that's done for you, and you can generally do things a lot quicker, and there's a lot more helper methods and things of that nature. So that's the next thing that I'd like to look at, is what options we have for interop libraries that we can call into. And there's actually many different interop libraries that are out there, but there's two that are very full-featured that we can use today. The first one I'd like to look at is actually the one that ships with InstallShield. And truth be told, I'm less familiar with this one. I've used the WIX interop library quite a bit more, but what we'll do is we'll add a reference to it here. And sorry, let's see. Monty just killed my screen. Let's see.
Sorry.
Sorry.
Who skipped this meeting that should be sitting there? Is it Ron?
I had to join another room so I could try and present to the screen, because it wouldn't let me present for one. Go ahead, sorry.
Okay, but all right. Okay, so let's see. We're looking for in the recent list the InstallShield interop.msi. Let's see here. Okay, it's not in my recent list. I'll actually have to browse for it. The InstallShield interop library is under Program Files, InstallShield, and it's in the InstallShield system folder.
version of .NET does it require?
I don't know offhand. That's a very good question. I don't know what they wrote the InstallShield Interop library in, but that we can find out quite easily. It's a good question. And the way that we find out, we can use something like .NET Reflector, which we don't have licenses for .NET Reflector. But there is a free tool that's similar to .NET Reflector called JetBrains.peek. This is also something that's very, very useful when you're using managed custom actions, because if you need to understand how something works in a third-party library, it'll decompile it for you. And here's the InstallShield Interop MSI. So let's take a look. And it looks like it's actually against .NET 4.5.
What, 20 under 2010? How is that possible?
I'm not certain. Oh, I'm sorry. It's 2011 that I already have loaded here. So let me load up the one from 2010.
For that matter, was 4.5 out when 2011 was out?
Yeah, that's what I'm thinking, but maybe Kerry has like some new updates applied on the server system, right? So.
No, I think I just have whatever the latest service packs are. Okay, let's get back to InstallShield 2010. InstallShield Interop MSI DLL. Here we are. Okay, and this one is linked against .NET 2.0. So, and also notably, JetBrains.peek knows how to decompile a .NET 2.0 assembly, whereas it looks like it doesn't support 4.5. Or this may have been obfuscated in InstallShield 2011. I'm not certain. Chances are it just doesn't support .NET 4.5. So now we can actually see all of the implementation details of the InstallShield Interop class here. So we had our reference to the InstallShield Interop, and now I'll actually get rid of what we were working on before here, and we'll try and redo this using the InstallShield Interop class. Add the InstallShield Interop namespace before we get access to anything. And you can see that, similar to my Interop class that I built from scratch, they have an MSI object that gives us access to most everything. A lot of MSI APIs and things of that nature. But most importantly, we need to first instantiate the install object using the handle to the MSI before we can really make use of a lot of this stuff. And let's see here. There's actually a method that lets us instantiate this from a handle, and I forget exactly how we do this. So I'm going to open up my reference sample project where I figured this out last night. And so here's how it looks with the InstallShield Interop library. Here we are. So there's a method within the MSI object called custom action handle that works as our constructor for the install object. Jump back over here. This one actually requires an int. So we can.
The number you have. Try your call again. Thank you.
Is that you or me?
That's me, apparently. Here, let me mute mine. Okay, so
the
now
number you have dialed is not in service. Please check the number and try your call again. Thank you.
Access now to all of our APIs and such. So this is the wrapped MSI do action, MSI enum component costs. There's also get feature info, get product property, get property, all of the same kind of API calls that you would expect if you were doing it from InstallScript or whatever. So taking get property as the example here, it's significantly simpler because it's a managed class. All it needs is the property name. When we instantiated it is when we dealt with the handle. So now it is all available to us like so. Have similarly enum types for all of the various errors that are possible. Do MSI success int. And there we have how to do it using the InstallShield Interop class way. So what I'd like to show you here, let's actually do something useful in this custom action and test it in InstallShield at this point. So what I'm going to do is I'm going to copy my reference code here. This basically is going to use MSI process message. Yes and no. So for those that are not familiar with MSI process message, it's actually kind of a Swiss Army knife in the Windows Installer API. It lets you write to the Windows Installer log. It lets you update the progress bar. And there's also a message type, as you can see here, message type warning, that lets you display a message box type thing. But it does so using the defined error dialog of the MSI package. So that's basically how we're using it here. And I'll have something a little more professional here, like hello world. And probably some of you have done something very much like this in InstallScript. So we create a record, we set the string value of field 1 of the record, and then we pass it off to MSI process message. And if we wanted to write to the log, we would basically just change the enum type from warning to something like info, and it writes to the log instead. We'll keep it as warning.
The warning won't write to the log. Is that what you're saying?
Correct. It'll only display in the message box, is my understanding. I could be wrong. It may write to the log. We can check. It's not often that I actually use this type of message box. It primarily is useful over message box when dealing with UAC, because it'll always show up on top of an MSI dialog, whereas message box won't necessarily. So. Okay, build succeeded for the custom action class. So let's go back to InstallShield, and actually before we do that, let's get the path to our new DLL that we compiled and get it from the output window. We browse to our custom action class. Now we have to browse to our method here. And this is where things can get sticky. From what I have found, this browser here can sometimes have trouble finding dependencies. I'm actually very glad that it worked this time. Chances are later on we will have problems with this. I've had many problems getting this class browser because it actually has to load the assembly and all of its direct dependencies in order for this view to show up correctly and walk the DLL in order to show us the public classes and methods. So what we've got here now is it figured out that it takes a single parameter that's an int32, and if we wanted, we could say use custom method signature here and give it the MSI handle. If we don't use a custom method signature, it's going to do this on the back end anyways for us. And by not specifying a return property, any integer we pass back is actually going to be the error code that's passed back to the Windows installer engine. So 0 for success, anything else for a failure of some sort. So let's sequence our custom action. Let's do it after cost finalize. The advantage of doing it here is if we screw it up and an error happens, then we can use the checkbox on the final dialog to just show the MSI log. And this probably will fail the first time we run it, which is actually what I want because it brings up the topic of handling dependencies in managed custom actions. So here it's running, and it failed. And what I'd like to show you is why it failed in the log. So InstallShield bootstraps every managed custom action. It does so it can instantiate the .NET framework out of process, mainly because the main MSI engine is actually hosting the .NET framework itself, or whatever version of the framework it determines it needs. You can actually see this MSI net assembly support. At the very beginning of the log, you can actually see it says loaded MS Core E, and that's because it has to load the framework in order to communicate with the framework when it's installing .NET assemblies to the global assembly cache or even registering local assemblies. So that's one of, I guess, the design concerns on why they didn't implement native support, is because it's already hosting an instance of the framework in order to do .NET assembly installation. So what we've got here is, let's scroll up a little bit, just give us some debug info as to what's going on. You have the .NET stack trace. Okay, and here we are. This is the issue. Couldn't resolve assembly by name, InstallShield Interop MSI. So basically what's happened here is when it loaded the assembly, it extracted it to the temp folder, and there was no dependency found. And this is because, of course, our .NET DLL does not include the InstallShield Interop MSI namespace. So it has to go out and find it. It's not in the temp folder, and it's not installed to the global assembly cache, so it fails. So how do we handle this? Well, InstallShield has provided us a way of doing it, but it's not actually within the custom actions view, unfortunately. We have to go to the direct editor, and we have to tell it explicitly that there's a dependency that needs to be included when that custom action is running. And we do that from the ISCLR wrap table, which I think I scrolled past. Here we are. And we have to add a new record for this custom action. It needs the custom action name, a name for the property, which of course, so the property will be dependency, and then a number for the order of the dependency to be extracted. So this will be dependency 0. If there's multiples, our second one would be 1, third one would be 2, and so on and so forth. And then the value is going to be the path on the build machine to the DLL to include as a dependency of this custom action. So we need to run out and go get the path to this InstallShield Interop MSI. And now InstallShield knows to actually include this DLL and extract it to the temp folder when it's running this custom action. So if we rebuild, and run again, that's on my other screen here, but we get our MSI error dialog themed message box running from a C# DLL. Pretty straightforward, except for the direct editor part. But, as you might expect, in the long run, this can be fairly time-consuming to actually implement. This is basically why I had created the static interop class that I use for less complicated type custom actions. There is another solution that's preferred by a lot of people, and that's actually the WIX custom action support. So let's hop back over to Visual Studio, and let's actually create ourselves a new WIX custom action. And we'll take a look at how it's actually structured. So it'll be under Windows Installer XML. And it'll be a C# custom action project. You can see right away it's a little bit different. We have actually a managed session object that gets passed through rather than a handle. So it's already instantiating a complex class that lets us just get started right away. Has a enum type action result that's passed back as the return value. We have a log method that's put in by default for our custom action. The custom action is marked with a custom action attribute, and it shows us basically how to return success or fail from this action result enum type. So we're already money ahead with this, and you can see from the session object we have access to a component object here, or actually rather a collection, do action, evaluate condition, format record, get property, all that kind of stuff that you would expect to see. So what we're going to do is we're actually going to implement the same custom action that we just did with the InstallShield interop library. I'm just, for the sake of quickness here, I'm going to copy it from my reference project. Just copying a couple lines. So we create a record with session.database.createRecord. Database obviously is the database object that has all the database related functions. We set field 1 of the MSI record that we created. And then we call into MSI process message, which is just this simple message function within the session object. Give it the message warning type, and then we pass it the record, and we're ready to go. And let's see here. What are our errors here? Microsoft deployment Windows installer must be included in the list of support files. So basically at build time it failed to load a dependency here. Now, there's a lot of weird issues that you'll run into like this, and the fix to a lot of them I have found is to downrev to something like .NET 2.0. That frequently fixes a lot of problems, mainly because a lot of stuff is compiled against .NET 2.0 or some variant of it like .NET 3 or 3.5 that are just extensions to the .NET 2.0 framework. And as well, .NET 2.0 inherently installs more assemblies to the global assembly cache. So I've actually used that as a fix where in assembly I was trying to use the .NET 4.0 version of it, for example, for whatever reason, was just dropped in the framework location but not available in the GAC. And as a way of dependency management, down-revving it to 2.0 made it a lot simpler at install time. Didn't have to go out and find the assembly. It was already in the global assembly cache for .NET 2. And now we build just fine. And what I'd like to show you at this point, before we actually integrate this into the installer, I'd like to show you the build output of the WIX custom action, because it's pretty interesting how they actually implement their custom actions compared to how InstallShield handles it or my Interop class handles things.
This is Paul Cost. I just had a comment on the previous error. I ran into that in my custom action.
What happened?
Can you guys hear me?
We still get an error. What did we miss? Oh, okay. Right. Down revving means we've got some newer stuff that we have to comment out. So system.link, for example.
Can you guys hear me? No. Okay.
I can hear you, but I don't think Kerry or Ravi can hear at their end.
Okay. I just had a comment about
I guess
about
that's
the error.
okay. I'm on the phone and Kerry is not hearing us. I'm hearing you.
Okay.
Okay. There's some problem with this. Let's see. Okay. So for some reason, the copy local flag was not set by default, and it didn't like it. So we should have it built at this point. There we are. So our output, aside from some dependencies and the debug symbols and such, we have WIX custom action.dll and WIX custom action ca.dll. One obviously is a lot bigger than the other. The WIX custom action.dll is just the .NET assembly that comprises our custom action that we just wrote. ca.dll is actually a native C++ DLL that we would call as a standard MSI custom action, and it contains all of the dependencies that have the copy local flag set. So basically at runtime, it's going to extract everything to the temp folder, and in fact, all this really is it's a self-extracting cab file that has exported functions. So if we were to extract it, you can see it actually contains all of our dependencies and a custom action config file, which actually we don't need to open this here. We can open it in Visual Studio. Custom action config file that tells us what versions of the framework it's allowed to run against. This can be a common issue if you're missing an entry here where it's valid to run against multiple framework versions, but you don't have a framework version listed here. And the other thing to make mention of, I mentioned that .NET 2.0 from this perspective is the same as 3.0 and 3.5. It actually mentions this here. Runtime version is still 2, and that's because 3.0 and 3.5 are extensions to the version 2.0 framework. And before we actually hop on over and integrate this into InstallShield, I wanted to show you one other thing about this custom action DLL, the native one. We'll first rename it to DLL. instead of cab. So if we take a look at it in Dependency Walker, we can see exactly how they've implemented this. So there's really just a couple of basic dependencies on MSI DLL, and we have to scroll through a bunch of null named functions here. We can see it actually exports our custom action name, counting down from an ordinal number of 128. So it actually seems as though there's an upper limit to the number of managed custom action entry points that you can have in a WIX custom action DLL because of this. So now we're ready to actually integrate this into InstallShield. And there's really a couple of ways that we can handle this. Let's go back to our custom actions and sequences view. Now, because we know one of these is a C++ DLL that's a self-extracting DLL with all of our managed dependencies, we can create it as a new MSI DLL. Call it WIX DLL CA. And this way, the MSI engine is none the wiser that it's actually a managed custom action. We just give it the function name, which, let's see what we have in Visual Studio here. It is custom action 1. And then we're done. Just need to sequence it. We'll remove our existing custom action. And there we are, our WIX custom action running as a C++ DLL within the installer. And this is the method that's preferred by a lot of people. The only downside being is that you'll need WIX installed on your build machine in order to compile this and get it integrated with InstallShield. But
so if you have WIX on a different machine than where your InstallShield IDE is, you still need WIX installed on the machine where the IDE is installed? Or could you build the DLLs and...
You could build the DLLs on the WIX machine, and then at that point, the DLL is completely self-contained. It's got, whatever WIX runtime bits it needs already contained within it.
Right. So the thing that I tried to do is build it on one machine that had Visual Studio and WIX installed, grab those DLLs and pull them over into my project, and then tried to add the DLL as a new managed custom action.
Right. I'm glad you brought that up, because that's actually what I'm talking about next. So this WIX CA.dll, let's see if we can get back to okay. Right. So this WIX CA.dll, custom action CA.dll, that, like I say, is a native DLL that contains the managed stuff. So if you try to set it up in InstallShield as a managed custom action, it's going to choke because it's not. actually a managed custom action. It's not a .NET assembly. It contains .NET assemblies. So the InstallShield class browser won't know what to do with it. And in fact, it's not valid to wire it up that way. If you want to call your WIX custom action using the InstallShield managed custom action support, you can do it. So you can actually author custom action DLLs that can be used directly in WIX as a native custom action, or you can call the same functions in InstallShield. Just there's a different way that you have to do it. And I'll show you that right now. This custom action DLL without the CA is the managed assembly that you're going to wire up to the InstallShield managed assembly support. But what you have to do first, because the WIX custom action entry point doesn't take an MSI handle, it takes an already instantiated WIX Interop library session object, you actually have to use the handle to instantiate the WIX session object. So you basically have to have a bootstrapper that InstallShield can call into, which then calls the WIX custom action entry point. And I'll show you that right here. Call it WIX wrapper, and it's going to take an int pointer. I believe the int pointer data type is what the WIX Interop library needs to instantiate a session. Let me see. Here we are. The session from handle is basically our constructor type function for the WIX session object. And we're going to say false because we do not own that handle. And so now that we have a session object, we can actually invoke the WIX custom action and call it from InstallShield. And of course, again, we're getting an action result back, so we have to cast it as an int, coming back from the WIX custom action. And this is the bootstrapper that you can now call from InstallShield, which we'll actually go ahead and set up now. Make sure that this actually compiles. New managed code, stored in binary table, wrapped WIX, just to differentiate it from the existing one. We'll grab the smaller of the two, which is the managed assembly. Now our class browser works, and we'll select our WIX wrapper function that we just defined that calls into this first one that takes, as you can see, the Windows installer session object coming from WIX. Give it the MSI handle. And since we know that there's a dependency here, because this interop class from WIX doesn't come from nowhere, and it has to be on the client machine somewhere for this to load up, we need to do the InstallShield trick with the ISCLR wrap table to tell it to include the WIX library as a dependency of this custom action. And this will have to be where WIX is installed on this machine. WIX 3.7 is what I'm using. Microsoft deployment.windows installer. insert wrapped WIX into the sequence, and we'll go ahead and we'll run it. And then we can see code reuse in work. Basically how we integrate the WIX DLL into InstallShield as a regular managed custom action. Exactly. Okay, so that is mostly what I have on regular .NET-based custom actions, either using the WIX way or the InstallShield way or what have you. So I guess before we take a few minutes and look at some of the install script stuff, did anyone have any questions?
What is the type of wrapper WIX? What type of custom action is that? That's not managed.
Wrapper will be a managed.
Right, wrapped WIX is a managed custom action. So on the back end, when you actually build the MSI, this type number ends up being a type 1 custom action because it's an InstallShield bootstrapper that ends up doing all of the magic on the back end. But when you see it in InstallShield, it'll actually be this, long type number. But when it builds, like I say, InstallShield, ends up putting its own C++ DLL that handles loading the framework, extracting the assemblies, what have you.
So managing the database or records using these is much easier than just using InstallScript, right?
Yes, yes. Yeah, the Interop libraries that either InstallShield or WIX provides, it's a lot easier. I will say I've not worked extensively with the InstallShield Interop class, but I do know the WIX Interop class. That's what I use to create the quick patch automation tool. It does some funny things with the way that it passes back the results of database queries. So it's not super great, but it's as of WIX 3.7. They may have fixed it.
Right, but again, even if we use InstallScript, I have run into bad formatted results or so. I guess it will still be better than the inherent InstallScript support.
Yeah.
So why did you choose with this managed DLL? Why did you choose to call it from InstallScript or invoke it from InstallScript rather than adding a custom action?
Oh, I haven't done it. I'm asking.
Oh, I thought you'd done this with.
Oh, that for the users that I did. I did not know about the interops that would have joined them. Remember, I think you had given me some code when we were working on some other problem when we couldn't implement the interface. But I thought that it would be just easier to create a C# DLL and then call it, because that I had done in the past.
Right, and that's what you have to do with a pure InstallScript project.
Right.
Right, but if you're using MSI, obviously this is going to be quicker and easier.
It was, I think it was MSI, but still, now I think I would rather go for this as opposed to that. Especially since it's giving all the logging and everything inbuilt. I don't have to do anything extra.
And error handling.
But in my custom action, I have to create, if I just create a straight up DLL, then I have to create functions for everything.
Right. That actually does remind me. I wanted to show you guys the helper functions that I have in the Interop class, because they're only in the Interop class that I wrote, but they can easily be translated into using the WIX or the InstallShield Interop class.
So what do you recommend? Using your Interop class or WIX? I think InstallShield is...
Well, so it depends. For anything of any significant complexity, I probably would go with the WIX Interop class because I'm more familiar with that. Then it becomes worthwhile to deal with the external dependency, trying to handle that, one way or the other. For very simple tasks, I prefer the Interop class that I wrote because you can just drop it in the Visual Studio solution and it's very quick to just do some very basic things. And then you don't have to worry about external dependencies. So the question of how complex the custom action, in my mind, tips the balance in favor of one or the other.
But what if we just, let's say, Garrett and I, we work on installs, and Garrett creates one DLL using WIX Interop. And he already has the framework in place. So if I want to add a new function to it, won't it be like he has to do the dependency and everything to make it work for the first time? So what if I come and just add a new class to that for my install, and then we just share the same DLL?
Yeah, I mean, it's very easy to do. That's what I like about the WIX solution is that, using the WIX solution and the WIX Interop, that probably has the most options for code sharing across, not just between different developers, but also people that are using WIX and people that are using InstallShield.
Because it doesn't hurt, right? Just having two functions for two installs in one year.
Right. The only caveat being that there does appear to be an upper limit to the number of exported functions.
Okay.
Right. But that's limited by the custom action attribute. That's actually what makes it export function, and that's only if you're using the self-extracting C++ type DLL with WIX. If you're calling it through the InstallShield managed support, there's no upper limit as far as I know.
Do you prefer one over the other? The managed C# or the C++?
It's a good question. I prefer, in InstallShield, I prefer using it as a managed DLL, just because the class browser is nice. It differentiates it to the naked eye between a regular C++ DLL and something that's different. Right. So that other people come along and they say, well, what is this? Oh, it's a C# DLL. That's what it's doing. So I like it for that in InstallShield. In WIX, obviously, you don't really have another option. WIX doesn't have any support for calling managed DLLs except for building as self-extractor type.
Oh, okay.
Right.
Yeah. Because I like the fact that all the dependencies are packaged inside the C++ kind of DLL. But it just, I think it adds one more dependency or one more layer between the actual code and the install shield. I would rather not do that.
Right.
Let me talk to the DLL directly.
Right. Yeah. Well, I mean, to a certain extent, you can't help but involve a bunch of middlemen with something like this. So, as far as what's more reliable, like the InstallShield way or the WIX way of doing it with the self-extractor, I mean, I would say there's more opportunity to run into problems with the InstallShield way as of today. The class browser, like I say, is kind of tricky with dependencies. The WIX way, it's very simple to build it and use it. But it also doesn't have as much functionality. It doesn't let you, pick from a large list of functions with a class browser. So.
And then let's say I have a DLL, a utility DLL, and in my install I call 3 different functions from that DLL at 3 different stages. Do I have to specify the dependency every time if there is a dependent DLL that it requires, or just once is good enough?
Well, so the dependencies are specified on a per custom action basis. So if you have separate custom actions, you need to specify the dependency for each of those custom actions. Because when the assembly loads, it's just like a native C++ DLL. If it's referenced as a direct dependency, it needs that assembly to be there when the assembly loads and not when it's actually trying to use it.
So what if I put it in the support files folder? The dependency, rather than adding it in the custom action, directly to the custom action, I just drop it in support file.
Probably not going to work because the support files folder is a subfolder of temp, and it either
some other temp.
I think it probably goes directly to the root of temp. I'm pretty sure it doesn't go to support dir. Right. So, I mean, you could potentially there's ways of implementing stuff in .NET to tell it to load a dependency like another .NET assembly from a specific path. So you might be able to kind of work it that way. I haven't tried that, so I couldn't tell you what the pitfalls are.
this might be easier. Once you get hang up with just add the dependency and be done.
Right, exactly.
Okay, cool.
Okay.
I'll admit that I wasn't completely listening all the time, futzing around with the presentation sort of thing. A lot of what you did in there to initially create the project and set up the right dependencies, can that be set up as like a template project where people could, so they don't have to go through all of the those machinations and they can just add the code in that they want?
You're talking about the Visual Studio project?
Yeah, the actual C# aspect of it.
Oh, right. Well, that is done for you if you're using the Wix way.
Okay.
We could probably work out how to make a Visual Studio template for if you're using either the wrapper class that I wrote or the InstallShield interop.
Yep.
I believe that wouldn't be too hard, but I haven't done it.
Yeah. I mean, I could see us having here's, from a solution point of view, you've got just an empty solution for each one of those methods out there that you could keep up to date going, oh, well, this changes or it's not 4.5, and then people could just go in and add the code versus having to create it, but we can discuss that later on.
Sure, and there's actually, that actually brings up one other point. Talking about all of the things necessary to, set up something that's usable with the InstallShield interop library. The InstallShield interop library, from a code perspective, is written so that you can use it in your installs, but I don't believe there's any official documentation on what the redistributable rights are on the InstallShield interop DLL. So that's probably something, before we go down that path, that's another reason why I haven't really used that, because that's kind of a question mark on, if they would care or not. I mean, the developers I know don't care, but who knows what the official policy is. So that's a question mark we probably want to hash out if we were going to take the approach of creating a Visual Studio template for the InstallShield interop stuff.
Absolutely, because as soon as we do that, people will just assume that it's the right way to go and that we've done the right due diligence there.
Right.
Okay.
Might ask if anybody on the call has any questions. Isn't there people on the call, Sandeep and
anybody out there in the world have questions? Can you still hear us?
I can hear you. I don't know if you can hear me. I tried talking a while ago.
Oh, I'm sorry. there was a lot of noise coming from my machine, so I had muted it at some point.
Okay.
So
you can look in the comments. I put my comment in there. I think it's closed, but I had just a comment about the .NET 4.0 thing that you brought up, that I was able to get a custom action to work by just adding the reference. I kind of stepped away, so I'm not sure if that's what you did as well, but if I added the reference directly, I was still able to use the .NET 4.0 coding standards without issue.
Okay, let me read through your chat log here.
Hey, Paul, while Carrie's reading, are you in the office today?
I am not in the office today, no.
All right. Well, we've got it. I should have given you more of a heads up. We've got a few folks in the office that aren't normally here. So Alex and Carrie from Chicago, and Chuck, who's not in the room right now, from Virginia. So if I think most of them are shipping out after work tonight. But if you happen to be in the office later, we can do some introductions.
I could certainly make a trip. I have to actually home early, my son, but
I don't think it's worth a special trip. I mean, they are some fine-looking gentlemen, but you can meet up with them online also.
Cool. I did have I don't know if you got to debugging. When I was looking to debug my custom action, one of the things that I ran into was that I have the original blog post somewhere. I couldn't find it, and when I looked for it, but I ended up by determining that the simplest way to debug a custom action is just to type debugger.launch and either comment and uncomment that line of code as needed, or to if you needed to, you could set up a sort of a config file that would be loaded at runtime that you could flip a switch and launch debug mode. I didn't know if you had any other suggestions beyond that.
No, I mean, I would agree. Debugger.launch, if you have the option available to you of debugging an issue on a machine that has Visual Studio, is certainly the easiest way of doing it. There's more esoteric ways of handling it. You can do it the old-fashioned MSI way, which is to just use the logging API to log absolutely everything and try to figure it out that way. There's if you're trying to debug a .NET crash of some sort, if your custom action is crashing, there's actually some pretty advanced ways of handling that. What you can do is, if you can manage to get a debug dump of the .NET process, then there's actually a very good blog by a I'm not sure what her current position is. Her name is Tess Ferrandez. She actually has some very good information on debugging .NET stuff. It's mostly geared towards ASP.NET, but it still kind of applies for all things debugging .NET. She walks you through actually several labs of using WinDBG to analyze a .NET crash dump, and actually walk through it to the point where you can see specifically what the values of certain parameters were when the crash occurred. So that's a pretty good resource if you end up in that kind of situation where you've got a crash where you're not sure what to do. Like I say, her name is Tess Ferrandez, and her blog is called If Broken It Is, Fix It You Should. Appropriately nerdy. So that's the more advanced way if you have that type of situation.
I do have a question that might be way outside the bounds of this call, but I found working with WIX, and I'm somewhat new to WIX. I found that interacting with the MSI UI to bring up to do things like bring up progress dialogues and things like that was problematic because it followed sort of a different model of synchronicity than you would expect, and so I couldn't really get messages to appear when I wanted to and interrupt the process, because they were basically MSI is basically a black box, and you need to kind of register yourself and say, all right, notify me as part of this, but you can't really just go in there and hook in and say, interrupt this, show this message, do this and this and this. If you try to do that, you basically get nothing, because it's either in a different thread or being run asynchronously or something. So I found quite a few blogs on that, but wasn't sure if this is a common error, a common issue when developing custom UIs specifically for custom action.
Yeah. So you're talking about more like trying to handle MSI progress messages and things of that nature. Is that right?
Yeah, and so basically my need was sort of to take a custom action and then launch an entire process as a custom action. And in this case, it was actually deploying a data tier application through SQL package. And so as that was going through its steps, I wanted to come back and say, all right, notify me here and here and here, and go through, bring up a separate progress dialog that would show the progress of that step run by that custom action. I couldn't get that to happen.
Okay. Yeah, that that is a tough thing to accomplish and have it synchronize nicely with MSI.
It seemed like the way to do that was to really create a WIX UI instead. Is that?
Yeah. Well, sort of. So MSI is designed such that you can really display one dialogue at a time, one MSI dialogue at a time. For the most part, there's some exemptions to that with regards to browse dialogues and things of that nature, but MSI really is designed with the idea that you're going to have one progress bar being shown, and they give you ways in the API to actually manipulate that progress bar using MSI process message. And I don't know if there's any good C# samples out there for it, but there is plenty of samples for that kind of thing in C++ and InstallScript that show you basically what APIs to call with what values to manipulate the main progress bar as opposed to your own. that's also based off of like an MSI dialog of some sort. Does that sound kind of like what you would be looking to accomplish, or are you pretty sold on like a separate modal dialog that's displayed?
I'm not sold. I had issues depending on where I was. I had issues with manipulating the main progress bar as well, and it definitely was. The more elegant approach would just be to leave it alone and let it do its thing, and not interrupt WIX and its concept of what the progress bar is trying to do, especially since it's already determined what the sizing of the project is, right. And I would have to go back and convince it otherwise. It seems like the main problem is just the order of operations, and that by the time my custom actions being loaded, it's too late.
Right. Yeah, and I suspect that's the case. MSI, like I say, the MSI API itself and the engine itself is what limits you on where and how you can manipulate the progress bar. So, first and foremost, you can only do it really in the execute sequence, and I believe it requires both an immediate and a deferred custom action in order to make that work. And so if that's outside of your use case for your custom action, then you're really very limited on what you can do in terms of manipulating the progress bar. Now,
therein lies the catch-22, because because it was actually copying files that didn't exist yet if I did deferred versus immediate.
Right. Now I've seen other people's compiled C++ custom actions that have worked by directly calling into Windows APIs to manipulate the MSI dialog through WinAPI outside of the MSI API. Personally, I've never made that work, but I've at least seen a proof of concept for that sort of thing. If you basically treat it as like an MFC dialog, which from what I have been told, it is basically just MFC dialogues, all of the native MSI dialogues, and that in theory you should be able to use WinAPI to directly post messages to its message loop and manipulate controls on the dialog and make it work that way. But from the standard things, you're not really going to get what you're looking for out of the MSI API, regardless of if it's InstallShield interop, WIX interop, whatever.
This is what we're talking about?
Yeah, exactly. So this is using the official. You can't see what's on Garrett's screen right now, but he's got some VB script for manipulating the progress bar, and he's doing it the official MSI way.
Mm-hmm. And this only works in the execute sequence?
Right. Yeah, you can't do it from the UI sequence. So.
Which is the only time you really want to manipulate the progress bar. You don't want to do it during.
Well, there's many people that have many reasons for doing many strange things. I'll say.
Let's not get into that.
Let's not get into that. But if you want to do something that's outside of what on the surface is reasonable, only manipulating the progress during the execute sequence, which sounds pretty reasonable from a design standpoint. If you do have a good reason for needing to do it outside of there, you can't use MSI API to do it.
All right. Well, at least I know I'm not crazy.
Right.
Or not in that regard, anyway.
You could want a progress bar if it was doing something in between.
Yeah, I mean, there's
an UI to just show the user that something's going on behind the scenes and wait for it.
Right. Well, and there's a lot of installs that will install other MSI packages near the end of the UI sequence.
Oh, all right.
So, I mean, that's a good reason to do so.
Yeah.
I don't know.
Yeah, and that's I've found also other, anecdotally, I've seen that probably had run into the same problem there, because I've seen other systems just basically invisibly launch those MSIs, and like, what are you doing? Where's my progress dialog? So.
Okay, well, we're pretty close to the end of our time here. I don't think we quite have time to get into, working with .NET stuff from InstallScript, but that was actually why I actually included. If you open the meeting invite, I definitely recommend if any of you guys are looking to do that. There's a lot of really helpful information in the second document, including common reasons for exceptions that you see raised from the co-create-object.net, .NET co-create-object, the steps needed to expose the assembly to the InstallScript functionality, and also a fix for that issue when you're trying to pass a string into a .NET function, where you're getting some strangeness there. So all of the most common issues that you see with that. And I also recommend as well, with the Interop class that I had created here, the helper functions that I'd created, it should be pretty easy to translate these into either the InstallShield or the WIX Interop libraries. But so I have one that basically lets you pass in the custom action data property. If you set it up with like a delimited list of key value pairs, it'll actually walk the string and then return one, based off of a named value.
Yeah, we have one of these functions for every sort of code we have. CV script, install script, we have this same function.
Yeah. Yeah. So
varying degrees of detail and error handling.
Right. Exactly. Also, I have a logging function.
So you have this in your interop?
Yeah.
And that seems to me to be something that you would want to have in like when Monty was talking about a template project, you would put it there, but you don't have it as part of the main.
I would have if I created a template, but I didn't create a template, so it's here.
So this kind of is your template in a sense. So
right.
when you don't use this, because you said that you use this for your more basic MSI,
right?
But for a larger, more complex one, you don't use this.
Right, I would use an Interop library because there's
But in order
a lot
to grab your custom action public properties,
do
you have a function like this that you include in a different?
Well, not yet.
Okay.
So the more complex custom actions that I've written, that I've done with the WIX Interop library, they generally, so far, haven't been deferred custom actions. So I haven't written a WIX version of it yet.
Oh, I see.
So, it may seem like I sit and write custom actions all day long in C#, but in production, I've actually only done a handful at this point. So this helper function, the logging function, I actually went through and added all the logic to generate MSI-style logging entries, complete with the timestamp indicating whether it's in the UI sequence or the execute sequence. It'll figure out the process ID and thread ID and use that notation as well, like you see in an MSI log, and so on and so forth. Format record basically just uses the MSI format record API, makes it a little easier to call, and that's it so far. Oh, also the same logging function, but written so that you can call it from a control event. So if you need entries written to your log file when you're running a custom action off of a button on a dialog, the regular MSI process message does not work in that case. It's a documented limitation of the MSI process message API. So what this does instead is it just sets a control event logger property over and over and over again with a value of whatever your log entry is. So it's kind of ugly, but it's the only way you can get entries into the log file from a control event on a button. So, and again, all of this stuff would be very simple to port over to either the InstallShield or the WIX Interop library. And we're at time. So before we wrap up, did we have any other questions, comments, concerns? Okay.
Thanks, Kerry. And we can always have follow-ups later on. I mean, this one was one we wanted to get while we had everybody in the office, but we can do more of these. And I'm in the process of putting together an ask alias it'll be for CM and RE in general, but it'll be something where it's not the SCM tame alias. Paul, you'll be included if you want to be, and where people that aren't us can ask questions of us, or people that are us can ask questions within the team without spamming, and just put whether it's the subject makes it appropriate, then we can all pick it up. So you'll see more from me on that very shortly, and you can ask Kerry questions directly, and we can have follow-up sessions later. Thanks, everyone, for attending.
Thank you.
Thank you, Kerry.
All right. Thanks, everyone. Take care.